segment we have discussed about ammonotalism. Now from this segment we will discuss about ureatalism and uricotalism. Now ureatalism, basically ureatalism means it is a mechanism or the process in which the organisms mainly excrete urea as their nitrogenous waste, right? So it is a type of excretion. It is a type of excretion in which excretory waste is urea. Okay? The excretory waste is urea. Now, what are the advantages of excreting urea over ammonia? That means, what are the advantages of ureatalism over ammonotalism? So, what are the advantages? So, first advantage is basically ammonia is highly toxic, right? Urea is least toxic as compared to ammonia. It is 1 lakh times less toxic as compared to ammonia, right? Urea is less toxic as compared to ammonia. And how much time it is less toxic? 1 lakh times less toxic. Organism body can store urea for a very long period of time without any damage to tissues and cells of the body, right? So urea can be stored for a long period of time in the body of an organism without any damage to the cells or the tissues. And one of the most important advantage of excreting urea is the required quantity of water. In order to remove 1 gram of urea, only 50 ml water is required. That means 10 times less water is required as compared to ammonia. In ammonia, 500 ml water. Here only 50 ml water is required. So 1 gram of urea excretion requires around 50 ml of water, right? So of course, mammals including human beings will prefer urea excretion, that is ureatalism. We are ureatelic organisms. We also excrete urea, right? So 1 gram of urea requires 550 ml of water for its excretion. Now its synthesis, where it is synthesized and how it is synthesized. Basically, urea synthesis takes place again in the liver through a cycle which is called as an ornithine cycle or urea cycle. So it takes place in liver by urea cycle, or it is also called as ornithine cycle, right? The reaction proceeds like this. Ammonia plus CO2 will form urea plus H2O, right? And this is basically the urea or ornithine cycle. Now in cartilaginous fishes, this is an exceptional case, very important one to remember for 4-mark MCQ in the NEET. In cartilaginous fishes, urea is synthesized by almost all the parts of the body except brain as well as heart. That is what you need to remember. And the example is elasmobranchus, including these sharks also, right? So in cartilaginous fishes, that is elasmobranchus, spellings are also very, very important. Urea production takes place in all the body parts except brain and heart. Now let us move on to the examples of organisms who are excreting urea, right? So we can have a long list of examples. And the first example is we as a human being. Basically, we do not write human beings, we write mammals. capacity to excrete urea, they are called as ureotelic organisms. So examples: ureotelic organisms, and the process is what we call it as ureotelism. Now we will take the examples of ureotelic organisms. Mammals including human beings. So mammals including human beings. We can take examples of aquatic mammal, desert mammal, kangaroo rats, etc. Desert mammal, right? We can take camel and kangaroo rat. In kangaroo rat, it is one of the adaptation towards various abiotic stressful conditions. Since kangaroo rat is basically a desert rat, it appears like kangaroo, that's why the name is kangaroo rat. Actually, it is not a kangaroo, it is a rat, but it appears like a kangaroo-like structure, that's why the name is kangaroo rat. It is a desert animal, okay? Desert animal, a mammal which always excrete urea, and kangaroo rat never ever drink water in his entire life period. Whatever water he is getting by the beta oxidation of fat or fatty acids. So we can take desert mammal, aquatic mammals like fishes, right? Whale we can take, cartilaginous sharks, rays also could be the best examples. We can have aquatic mammal. We have taken desert mammal and mammals including only, that is terrestrial mammals. So aquatic mammals we can include whale, right? We can include cartilaginous fishes like sharks and rays. And one example that we have written over here also, that is cartilaginous fishes, that is elasmobranchus. All over the body throughout the time urea is synthesized except two tissues, that is brain as well as where it is acting as a toxic, right? Now in man, this urea accounts for 80 to 90% of the total nitrogenous waste, right? Specifically human beings. Urea accounts for 80 to 90% of total nitrogenous waste, right? So this is all about ureatalism. Now the third nitrogenous waste is uric acid, which is the least toxic, right? So let us discuss uricotalism. Those who are excreting ammonia, they are called as ammonotelic organism, and the process is called as ammonotalism. Those who are excreting urea organisms are called as ureotelic organisms, and the process of the mechanism is called as ureatalism. Those who are excreting uric acid, they are called as uricotalism, right? The process, and the organisms are called as uricotelic organisms. Uricotelic organisms and uricotalism is the name of the process. So what happens in this uricotalism? In uricotalism, the main nitrogenous waste or the main excretory waste is uric acid, right? It is a type of excretion in which, or we can simply write, main nitrogenous waste excreted is uric acid. Now this uric acid, basically formation is a complex process and it is energy dependent. It is formed by the purines adenine and guanine, right? So formation, it is a complex process and energy dependent. That means in order to excrete that is uric acid, we need to first synthesize, organism must synthesize uric acid, then and then only they could be able to excrete uric acid as such, right? It is a complex process, energy dependent, but we are wasting energy for some advantage only. What are the advantages that we will discuss? So it is a complex process and energy dependent, right? It is produced from ammonia basically in the liver, but some amount of uric acid is also synthesized in kidney, right? since it is a complex process and energy dependent process also. So why the body of the organisms synthesizes uric acid? Like, what are the advantages? The first advantage is it is least toxic among the three. The toxicity number is third. Highest toxicity is of ammonia, then moderate is of urea, and least or the less toxic is uric acid. So it is less toxic than ammonia and even urea also. It is almost insoluble in water. So water quantity which is required is almost less or negligible. It is almost insoluble in water. If you remember, when we have discussed Ureatalism, the ammonia, it was highly soluble in water. Solubility was very high. And uric acid is almost insoluble in water. For excretion of 1 gram of uric acid, the quantity of water required is, if you heard, it will be like, you will be amazed. It is only 10 ml, right? So 1 gram uric acid excretion requires only 10 ml of water. It requires only 10 ml of water, right? And this uric acid is basically excreted in the form of this solid crystals. So we can take the examples of birds, reptiles like snakes, lizards in this category. Right? So examples of uricotelic organisms are birds, reptiles, birds and reptiles like snakes, lizards, insects like cockroaches, right? The white structures, the white paste that is removed by the majority of the birds is basically urea. Color may be different. That different color is because of the undigested waste product. This uric acid basically appears as a white or whitish crystal. This is exploited. That means it is used commercially to prepare uric acid crystals, right? And these droppings of birds basically means that white droplets, right? The excreta, the fecal waste. Dropping of birds is what we call it as guanos. Guanos. And from this guanos, this uric acid crystals are separated and used commercially in many laboratory as a laboratory grade reagent, as an LR reagent, right? So this is all about the three major nitrogenous waste that is or that are excreted by the majority of the organisms: ammonia, urea and uric